Very good afternoon, everyone, and thank you so much for having us here today. This afternoon, MPA's presentation will be done over two small segments. The first part will be covered by me. I will just give you an operational settings, sense of the operational environment within which MPA operates, to hopefully give you a sense, a good appreciation of what we are doing here. And then the second part will be taken on by Lawrence, my colleagues. He will just go through in greater details about the application of the digital twins in the maritime context. So very quickly about what I do within MPA. My team and I, basically, we look at the entire spectrum of events that could impact the maritime industry adversely. So traditionally, we are looking at events like oil and chemical spill. And yes, indeed, we have been kept quite busy for the past few months. Increasingly, we are also looking at new threats that's emerging, arising from climate change, as well as the news of new marine fuels. Just something quick about myself. Before I joined MPA, I started my career as an emergency responder with the SCDF. So I'm happy to see a lot of ex-colleagues. I believe they gave a presentation earlier on today. And then I joined the aviation, and then somehow I got into the maritime. I think the maritime sector is a fairly resilient sector, even though COVID has impacted the industry, but it continued to be resilient. And I think the maritime sector is geared towards a very exciting time. Singapore's history and development has always been closely associated with port activities and how we grew from a fishing village to now this economic hub. And the statistics have shown also in last year, we continue to set new records. I think because of our strategic locations and the kind of connectivity we have with the ports all over the world, that leads us to become one of the world's biggest transshipment hub in terms of vessels arrival and in terms of container throughput. The other thing that we do is also that we provide these bunkering services to vessels that's coming through our ports as they pass through us and then going on for their onward journey. So because of all this, I think the numbers have shown, and in fact, these numbers were reported last month, and it shows that there's exciting time ahead. But equally as well, it's also some challenges that we see. Some of them not just peculiar to the maritime, but it cuts across. Some challenges are more peculiar to maritime. Take, for example, the climate change. I think there will be tremendous efforts in terms of pursuing the net zero targets by 2050. I think all these measures will come not just costly, will also require quite a fundamental review of the current business model. Next will be, in terms of the past 2 to 3 years, what we have seen around the region, the geopolitical tension and conflicts. These will also potentially be affecting sea trades, be impacting costs in terms of higher insurance coverage, in terms of longer fuel consumption as vessels have to navigate along a longer route. Now, in terms of the resource scarcity, the maritime industries is an industry that perhaps not many Singaporeans look forward to work in. They perceive jobs as dull, boring, and dirty, but increasingly we are using technology to change how people perceive the jobs in maritime industries. So we want to make it more appealing and more sexy for new entrants to join maritime, so that as the current workforce ages, there will be people that can continue to replace the older workers. And the other part is about incident management, which I want to touch on using these slides. Now, this really gives you the context to how within the area that MPA operates. Now, within our Singapore port limits, we are a very busy port. In terms of the vessel traffics, there are about 1,000 vessels at any point in time in our Singapore ports. And that translates to a vessel movement every 2 to 3 minutes. That means every 2 to 3 minutes, a vessel either leaves or arrives in the port of Singapore. And to do that, of course, we have very state-of-the-art vessel traffic management to manage the traffic so that it is both safe and efficient. Now, beyond the Singapore port limits, we look at the wider region, which is the Singapore Maritime Search and Rescue region. Now, this area, it is a wider area, of course, and it spans over 1 million square kilometers in terms of area, all the way to South China Sea. Now, this is an international obligation that's tasked to MPA in that we are supposed to render assistance to any vessels that encounter mishap or medical emergencies within that area. And beyond that, MSR, okay, is also the Singapore flagships that could be traveling at any part of the world. And in that regard, the Singapore Registry of Ships, the SRS, plays a very critical role in the maritime environment by ensuring that these ships that are being registered under us continue to operate very safely. So this gives you a sense of the operating environment that MPA operates in. So as we embark on our efforts towards decarbonization, the maritime sector is heading towards a multi-fuel transition to reach this net zero target by 2050. And one of the initiatives includes the using of alternate fuels. We are looking at different types of alternate fuels to eventually power the vessels within the industry. So while these new fuels presents new growth opportunities, the same challenges could also present itself, okay, in the form of how these chemicals will behave when we scale them up in terms of operations. So take, for example, ammonia. It is very attractive and appealing as an alternative fuel source because it is high energy density and it's very suitable for long-range shipping operations. But however, ammonia, when it's dissolved in water, apparently is very harmful for marine growth. So that is really some of the consideration we have to bear in mind. And of course, if not handled properly, the accidental risk of these chemical plumes can pose significant risk to port operations. Now, this gives you an example of methanol incidents that has happened over the years. So again, like ammonia, methanol is also a very attractive candidate as an alternative marine fuel in that it is low carbon and high octane. Okay, but methanol, as we know, is also very toxic if it's inhaled or if it's ingested or if it's absorbed through the context. Okay, and the other danger is also that methanol burns with an invisible flame. So if you do not have a detector, okay, you are not able to see the danger of it just using your naked eyes. So therefore, it makes a lot of sense for us to work with the research institutions and the industry partners to really better understand the behavior of these alternative marine fuels using tools, and so that we understand this behavior better. And this is one example whereby we use a plume modeling, and we try to ingest both the water and sea data into the plume modeling, and then have a sense of how it will look like, okay, in terms of the 3D effects of it. And then we use this information as planning parameters into our contingency planning. Now, in terms of what would be the kind of safety zone that we want to establish, and whether or not evacuation will be needed if something indeed spills, and to what extent the evacuation has to be effected. And also, last but not least, the direction of approach for the response vessels if they do have to get close to the source of the leak in order to render assistance. So all these are useful planning parameters to then be pumped into our contingency plans. Now, this is also another success story that we are very happy to share. It's the world's first operational use of ammonia as a marine fuel that took place in Singapore just last year, March 2024. So this project is a 2-year-long journey, and it all started with the company, which is Fortitude Green Pioneer. You can see that ship, that blue ship with a green circle. That is the ship that was used as part of the trial. Now, in 2020, the retrofitting of the vessels took place way back in Australia at their land-based testing facilities. And then it continued to go through several rounds of extensive equipment testing as well as engine testing, just to make sure that it is a viable model. So what they did was to retrofit it so that the vessel itself can take both ammonia as well as a conventional fuel to power it. So in that sense, it is a dual fuel vessel. Now, to make sure that the operations are ready to be mounted in Singapore, we also conducted a series of safety workshops and studies just to make sure that the vessel is in good seaworthy condition. So eventually, when it reaches Singapore, right, what we did was also to have our emergency op center and to involve all the stakeholders to make sure that we come in and monitor the operation so that everything goes as smoothly as per plan. So that is important. And at the same time, you can see that we also have the proof modeling and also deployed the drones to monitor the situation to gather that situational awareness. The proof modeling was done in jointly developed with our research institutions such as the NTU and NUS, their research outfits, and also with A-STAR. So that definitely gave us the peace of mind and the level of confidence that the things will be able, the operations will be able to proceed as per plan. Now, all in, the entire trial took over about 7 weeks. I think the time taken was long because we wanted to make sure that every individual component of the vessels was rigorously tested right before the trial operations began. And eventually, when it was successfully conducted in March 2024, so I think that gave us the level of confidence that such trials can be undertaken in Singapore under that kind of very facilitative regulatory environment, and also, more importantly, to demonstrate the strong ecosystem with the research, with our research counterparts, okay, to make sure that we are able to undertake such operations and to scale them up if necessary in the future. And of course, after that successful conduct, the MPA as well as the company went on several international forums to share some of the key lessons learned. So this was something that we're very happy to share in our journey towards decarbonization in the maritime industry. Now, as part of the training, of course, the crew had to undergo personal protection equipment training in terms of gearing themselves up, in terms of all the various equipment and the detectors that they need to gear. And the picture there is actually our chief executive from MPA. So he also went down to be on the ground with the crew to be part of the training, really just to emphasize that importance of PP training as well as that readiness. Okay, so hopefully what I've shared gives you that operational setting. So now pass on to Lawrence. Okay, he will just talk a little bit more about the digital twin application in our maritime context. Okay, Lawrence, please.
Okay. Hi, everyone. So thanks, William. So as Singapore moves towards the alternative fuels bunkering, so the risk of chemical spills actually involving ammonia and methanol actually pose risks for ports, vessels, and also the crew involved. So utilizing 3D geospatial visualization, we can actually see how this substance actually disperses in both air and water. taking into account factors such as the vessels involved, port infrastructure, and also weather conditions as well. So digital twin are virtual representations that actually replicate real-world systems in real time. And by creating a digital twin, we can actually simulate and plan for these bunkering operations, identifying vulnerabilities in real time while developing effective strategies to protect both the people and our environment as well. So MPA actually collaborated with Esri Singapore and also the research institutes that my colleague mentioned just now, NTU and NUS, to actually develop a methanol plume model web app that actually integrates real-time data feed into the maritime digital twin. And this platform supports a safe, informed decisions for the methanol bunkering within the Port of Singapore. So as we can see on the slide, how the plume actually dispersed via air and sea as well, it is a proof of concept for the digital twin to actually launch and also plan for bunkering operations that will happen in the future, and to simulate potential leaks when we actually ingest weather data as well and see how the plume actually flows accordingly. So on bunkering day, you actually ingest real-time conditions to actually predict the plume dispersion and guiding the emergency responses effectively. So as we continue to enhance the maritime digital twin, the system will be a key enabler in driving the transformation for shipping and port operations as well. So these are some of the use cases that we like to actually bring to the maritime digital twin to continue to enhance it. Thank you.